Hey, I'm going to tell you about a cool concept called supercooling. Supercooling is the cooling of a liquid down below its normal freezing temperature without it turning to a solid. You're like, well, wait a minute. If the freezing temperature is this temperature at which it turns into a solid, how could you cool it below that? We're going to find out. Supercooling is common in water in situations in which there are no ice crystals or other what we call nucleation sites present. You see, in order for the crystals to actually begin forming, the water molecules that are in this liquid have to kind of stop moving around each other so much so they can settle into a position, rotate into the positive and negative orientations, and lock into place as a crystal. And as long as the molecules are kind of just moving around each other, they're never able to quite find the right orientation to lock into place to allow the crystal to start to expand. And so typically they need a nucleation site. It might be a piece of dust, it might be an imperfection on the container it's in, it might be an ice crystal. They need something they can essentially attach to lock into the right orientation for things to start attaching from there. So as long as it doesn't get shaken, it's going to remain a liquid. In fact, you can try this experiment at home. If you get to a really cold morning, you know it's going to be one of those clear nights where the temperature is going to drop below freezing. I recommend you take an unopened or maybe even a case of unopened water bottles, so sealed water bottles from the store, and put them out in the cold of the night. In the morning, you'll probably notice that they're still liquid, even though there's frost and there's ice around. The water molecules are moving over themselves. They're not fixed into position, so they don't have the chance to lock into that crystalline structure, that hexagonal structure that you see like this, that will form ice cubes or snowflakes. And so, since they're not fixed into place, they can go down quite a number of degrees, 5 or 6 degrees even, below the freezing point without freezing solid. So if you take these water bottles and put them out in a night that, let's say it's going to get down to 28 degrees Fahrenheit or 26 degrees Fahrenheit, those water bottles might not freeze in the night as long as there's no nucleation sites inside of those water bottles. That's why I say use like a 6-pack or a case of them, because if you just do one water bottle, it might be frozen in the morning if there happens to be some imperfection or impurity in there. But usually if you've got several of them, at least one of them is going to be supercooled. So in order for the ice to form, though, they have to align themselves up perfectly to form that crystal. Now there's a way you can make that happen. Give it some kind of disturbance that allows at least some of the molecules to move into position and to start locking. And you might get something like this. So you can take this bottle, very carefully whack it on the table, and almost instantly ice will begin to form as that nucleation site has been created, and then all the other water molecules can lock into position. In this upper image you see up here, you can see that they're slowly pouring this water out of this supercooled bottle, and they had a little ice piece on the tray that created the nucleation site, and then the ice just goes from there as you add the water. So that's supercooling. I recommend you give it a try this winter. It's pretty fun. By the way, liquid water droplets in clouds are often below the freezing point of 0 degrees Celsius. So this is particularly true in the winter season where you see the clouds moving over. They're several thousand feet up, and they are supercooled. They're still a liquid, these droplets, but they are below the freezing point. And a lot of times when they hit a mountain and they hit the trees and the rocks that are up there, as they hit up against those branches, those create the nucleation sites and ice begins to form. And so sometimes you'll wake up in the morning on a cloudy day and then you'll see the cloud move off the mountain and you'll leave a layer of ice on the surface up the top of the mountain, or ice forming off of the trees. That is from supercooled water in the atmosphere. In fact, here's an image of hoarfrost that is formed on the summit of Mount Washington in New Hampshire, where they have a weather station up at over 6,000 feet there. And as the winds blow that supercooled water, it basically freezes solid on every sign and building and antenna. Everything just forms these ice layers as the supercooled water hits it and instantly freezes to it.